Okay, so now let's take a look at alkalosis. Okay, so again, we have two types of alkalosis, respiratory alkalosis and metabolic alkalosis. Respiratory alkalosis is going to happen, it's alkalosis with a respiratory origin. It's going to happen pretty rarely. Basically, it's caused by hyperventilation. Um, and like I mentioned um, at the end of the last slide, if an alkalosis is respiratory in origin, we're going to have to respond to that in our kidneys because our lungs, our breathing can't compensate for that because that's the source of the problem. Okay. Metabolic alkalosis is going to be due to other causes, such as excessive vomiting. Okay, so we lose acid when we vomit, or excessive antacid ingestion. And it's typically accompanied by respiratory compensation. Again, same point that I made earlier. Okay, so just like with acidosis, we can distinguish between respiratory and metabolic alkalosis by looking at bicarbonate levels. Okay, so let's consider what direction this equation is going to go in if we have a respiratory alkalosis, and then what is bicarbonate going to look like. So take a moment to think about that, hit pause if you need to. Okay, so if our alkalosis is respiratory in origin, so this is going to be like if we are breathing too much, basically, okay, that's going to cause our CO2 to go down. That is going to pull our equation in the leftward direction, thereby causing the alkalosis, first of all, and then causing our bicarbonate levels to go down. What do you think we're going to do next? Okay, so now we're going to consider what is going to happen if our alkalosis is metabolic in origin, and what are our bicarbonate levels going to look like in this case. So take a moment to think about that. Okay, so if our alkalosis is metabolic in origin, it's going to be this part of the equation that is responsible for the alkalosis. Okay, so our H plus is going to go down, as you can see in this figure here. When our H plus goes down, that is going to pull our equilibrium reaction in the rightward direction, and that is going to cause our bicarbonate to increase. Okay, so once again, you can see the differences between our respiratory and our metabolic alkalosis reflected in the bicarbonate levels. And like I mentioned before, if we have an alkalosis or even an acidosis that is metabolic in origin, our respiratory system is going to respond by breathing faster or slower, increasing or decreasing ventilation to try to compensate for that. Okay. However, like I mentioned before, if the problem is originating in the respiratory system, then we can't correct it using the respiratory system. And therefore, we will have to rely on our kidneys to try to achieve that acid-base balance. Okay. All right, so I'm going to close this video by showing you this table that basically summarizes everything we just went over in the previous slides. One thing that I do want to comment on is here you can see in metabolic acidosis and alkalosis that the PCO2 levels can be described as normal. So basically to address what's going on here is initially what's going to happen as a direct effect of the metabolic source of acid or source of base or loss of acid is you are going to get an increase or decrease in PCO2, but then the respiratory system will respond to that, and that can bring your PCO2 levels back to normal. Okay.